So when we're graphing these ones, we want to look at the endpoint behavior of these functions. And endpoint behavior is essentially horizontal asymptotes and slant asymptotes. So what's happening as x goes to infinity or negative infinity? If there's a limit, okay, that means that it's going to go to a certain y value. That's a horizontal asymptote. Now slant asymptotes are also endpoint behavior, but they occur when the degree on top is 1 bigger than the degree on bottom. And what ends up happening is, as x goes to infinity, this graph will behave like a linear function. And we find that linear function through long division. Okay, so let's try this one out. So let's start from the beginning. Let's find the zeros. So I want to find the zeros of this graph. Okay, so the zeros, I'm going to find the zeros by factoring the numerator here. So I end up with f of x is equal to 3x plus 2, x plus 1, all over x minus 4. Okay, so then make that equal to 0. We get x is equal to -1, -2/3. Okay, so we'll put those points into the graph. Let's say that's about -1 here and -2/3 about here. And let's mark that out. And let's start a table of values here so that we can start keeping track of some points here. So I'm going to draw my table of values here. Okay, so I end up with -1, -2/3, 0, 0. Might as well work out a y-intercept here as well. So y-intercept is going to be when x is 0. And I plug that in, I'm going to get -1/2. So let's say that's going to be down here somewhere. Okay, so I'm going to make my y scale a little bit different than my x scale. Okay, so there are my zeros. Okay, so I want to now work on the vertical asymptote, slant asymptote. Well, my vertical asymptote is very straightforward. It's going to be where the denominator is at x equals 4. Okay, maybe somewhere around there. Okay, and the slant asymptote, this is what we were just talking about. We're going to find this through long division. So we're going to divide the x minus 4 into the 3x squared plus 5x plus 2. So do my long division. It's going to be 3x squared minus 12x. That's 17x plus 2 plus 17. So I get 17x minus 17 times 4 is 68. So I get a remainder of positive 70. Okay, so what does this mean? This means that I can rewrite this f of x equation in its division form. Okay, so this is the division statement, 3x plus 17 plus the remainder over divisor. So what's happening is, as x gets really, really big, this term essentially becomes 0 because we have a really big denominator. So the graph starts behaving like this 3x plus 17 function. So this is why the slant asymptote shows up, because as x gets large, the graph starts behaving like this quotient. Okay, so I'm going to draw that in. Let's kind of draw it in like this. So this is going to be y equals 3x plus 17. Okay, so let's say that's about 17 there. Okay, so there's my slant asymptotes, and from these slant asymptotes, I can actually sketch in my graph. Because I have it's going to go through here like this. It's going to go through that y-intercept, follow the y-axis here, like that, and then we're going to have some piece up here, and we're going to find the vertices still. Okay, so but this is what it looks like. This is what we've done, and some of us may have done this in grade 12 even. So there's our graphs, and we just need to now figure out our max and min points. Okay, so we're going to find max and min